So first, to start with, we are going to see about UJT. So UJT is a uni junction transistor. So we have seen about BJT. BJT is a bipolar junction transistor. So bipolar, it is going to have the current because of both majority carriers and minority carriers. So electrons and holes. But here UJT is not unipolar junction transistor. See here, it is uni junction transistor. So usually conventional BJTs will have two PN junctions, but this UJT is going to have only one PN junction. So that is why it is called as uni junction transistor UJT. So UJT is a three-terminal device. It is also a thyristor. It's a three-terminal device, and since it is going to have only one PN junction, it is going to be called as uni junction transistor or UJT, and it has three leads, or you can say it has three terminals. Okay, so diagram for UJT is given here. See here, you have a N-type material. In that, I'm going to have a P-type material, and that from the P-type, whatever terminal you take, it is going to be emitter. The other two sides of N-type terminals are called as base 1 and base 2. And the diagram for UJT is same as the diagram for transistor, except that you have a bend in the emitter. The arrow mark indicates the direction of flow of emitter current. So usually for BJT, the diagram will be like this. We have seen the symbol for BJT is like this, right? So this is going to be emitter, this is going to be collector, and this is going to be base. But I'm going to make a slight change here. So since I have emitter and base 1 and base 2, so emitter will be coming here, base 1, base 2, and emitter terminal is slightly bent. Because if you keep it straight, it is the diagram for FET, right? So I should have unique diagram for each device. So I cannot reuse the same diagram for two devices, then it will lead to confusion, right? So a slight bend is given to the emitter terminal with an arrow mark to indicate the flow of emitter current. Okay, so that this is the construction of UJT is also very simple. It is a single PN junction. It is going to have only one PN junction, and compared to conventional PN junction diode, the P and N regions will be uniform and of same size. But here you see I have a bulk N-type material. In that a small region I am going to have P-type growth. P-type region is grown in that small region. So that P-type is going to be my emitter, and N-type I'm going to have base 1 and base 2. So whenever you have a PN junction, you will be having a depletion region formed in between the two regions. So that depletion region is what I have highlighted now. So around the P region, between the N region, you will have the depletion region being formed. Okay, so see here the construction of UJT is very simple. So I'm going to take a lightly doped N-type silicon bar. So you can see here I'm going to take an N-type silicon bar, and in that I'm going to fabricate a P-type heavily doped material closer to B2. The condition is the P-type should be heavily doped. I can call it as P+. Even you can call it as P+. A heavily doped junction, usually we put a suffix plus, right? So I can consider this to be a P+ region, and the condition is this P+ region should be close to base 2. So the reason is not known. So they have found, by fabrication, they have found that the device is going to perform well when my heavily doped P region is close to base 2. So see here, I'm going to take an N-type silicon bar, which is very lightly doped, and in that I'm going to grow a heavily doped P-type material one side close to B2. So the P-type region which I am growing should be closer to base 2 and far away from base 1. So therefore, you can see you have a PN junction getting formed. So the concept of depletion region will also come into picture. The circuit symbol of UJT is shown. So I have explained you why the symbol of UJT is there. The emitter leg is drawn at an angle to the vertical, and the arrow mark indicates the direction of conventional current. So emitter is bent and drawn just to differentiate it from MOSFET, because you can see all the FET family also will have the same equivalent circuit. So if you want to differentiate your UJT from the family of if you want to differentiate UJT from the family of MOSFET and JFET, you have to go for this special type of symbol. So emitter is bent, and this arrow mark indicates the direction of flow of conventional current, which means that the electronic current will flow away from the emitter. conventional current is flowing into the emitter, so the electronic current will be flowing away from the emitter. So understand this concept very well. And the equivalent circuit for UJT is given. You have two base regions, so definitely you have, when you have two wires coming out of base 1 and base 2, you will have two resistance RB2 and RB1, and you have a PN junction. Whenever you have a PN junction, you can replace it with a diode, and between emitter and the midpoint of base 1 and base 2, you will be having this diode, and the voltage across emitter is VE, and voltage across RB1 is V1, and the total base voltage across B1 and B2 is VBB. So these parameters are defined for UJT. So remember the emitter voltage, the voltage across RB1 is V1, and VBB is the voltage spread across B1 and B2. So since you have a PN region formed between emitter and the region between the base 1 and base 2, I am replacing that with a forward biased diode, and base 2 will have a resistance and base 1 will have a resistance, and we are more bothered about the resistance across base 1 V1. I'm going to denote it by V1. The total base voltage applied across the entire base region is VBB. So remember these notations. So when we analyze the functionality of this device, we will relate everything with respect to VE, V1 and